To solve another Leetcode problem 2429, minimize the XOR. So we are given two integer numbers, nums1 and nums2, and we need to find the positive integer x such that x has the same number of set bits as num2. So this is going to be easy. So for example, in num2, if it is 5, the set bit is going to be 2. So it is going to have the number of set bits is going to be 2. And the second one, the value x or nums1 is minimal. So for example, if we are having number 3, so the binary representation of 3 is 1 and 1, and we're going to have a set base of 2. So in order to make the XOR operation smaller, so definitely we're going to choose 1 1. Because for this 1 1 and 1 1, it's going to be 0 and it's going to be smaller. So the final answer is going to be 3. So this is the easy case. So this means the number of the set bits equal to the number of the set bits of nums1. So if the number of the set bits of num2 equal to the number of set bits in nums1, so definitely we're going to return num1 directly, because if the set bits are equal, definitely we just need to use them and to make it a 0, because 0 is minimal. So what if it is not? So for example, I'm gonna use some other examples. So for example, I have a 101. So this is one of my numbers. It is 5. So this is number 1. But my set base is 1. So what I gonna do? So I have a number 1. So this is n1 gonna equal to this number. Actually, it is 5. And my set base for number 2, I don't need to check which number it is, but my set base is 1. So how can I make it smaller? Will I use this bit XOR this bit, or this one can also be this bit, can XOR this bit? Actually, I need to. So if it is smaller, I need to use XOR this bit. Basically I need to consume from the left to the right. So this means my number gonna be something like 4. 4 XOR 5 is gonna be 1, and 1 is the minimal. So this means if the number of the set bits of number 2 is less than the number of the set bits of number 1, so we're gonna check from the right to the left side. If there is a 1, we're gonna set it to if there is we're gonna check it from the right to the left side, because we're gonna keep this 1 0 0. But how can we keep this 1 0 0? We just need to use the XOR operation to keep this 1 0 0. Actually, we need to use this number 1 0 0 4 with XOR 5. It's going to be the minimum number of 1. But we can do it reversely. Because our final result is going to be 1. 1 is the minimum. So we can also do it like that. We can just use the XOR operation, and this is our minimum number, and XOR this number 5. So it's going to be our result. It's going to be 1 0 0. So this means if this number, the count of the set bits, the number of set bits of nums2 is less than the number of set bits of number 1, so we're going to check it from the right to the left, and we're going to use the and we're going to set the bit from the right to the left. If there's a 1, we're going to set it to 0. So this means it's going to be the number of 4. So 4 XOR 5, it's going to be 1. So this is exactly what we are doing. How can we get this 4? Actually, we can directly use the XOR operation from the right to the left. So this is one of the cases. But what if our set base is more than 2? So for nums1, it is 5 still. But our set base for nums2, the number of set base is going to be 3. So what are we going to do? So basically this means the set base is going to be more than the number of set base of nums1. So if it is more than that, definitely we're going to use this one and this one we already consumed. But what about in between? We still need a 1 because this is a 0 and this is the closest to 0. Yeah. So this means still we're gonna check it from the right to the left. This one and this one is okay. Yeah, but we're gonna check the 0. If there's a 0 from the left to the right, we're gonna set it as 1. So for example, this number is gonna be this one. Yeah. So this is gonna be nums 1. And then yeah, we use the XOR operation. So it's gonna be something like 1 0. So it's gonna be 2. So instead of we're gonna make it like 1 1 0 1. If we check it from the check the zeros from the left to the right, it is not the biggest number because after XOR, it's gonna be 1 0 0. It's gonna be 4 instead of 2. Actually, our answer is gonna be 2. Yeah. So this means if the number of set bits of number 2 is more than the number of set bits of number 1, we're gonna check from the left to the right. If there's a 0, we're gonna set it to 1, and it's gonna be the final answer. Yeah. There are only two different cases. One case is we're gonna set 1 to 0. Another case is we're gonna set 0 to 1 for nums 1. Yeah. Now let's just try to solve it. So we're gonna prepare a counter as the set bit. It's gonna be nums 1 dot bit count and nums 2 dot bit count. So we're gonna count the number of set bits of num 1 and nums 2 at the same time. Now we're gonna check if this is C2. Yeah, if C2 is more than C1, so this means the number of set bits of number 2 is more than the number of set bits of the nums 1. Yeah, so for example, it is 3. So basically, we need to check from the right to the left. If there's a 0, we're gonna set it to 1. If there's a 0, we're gonna set it to 1. But how can we set this 0 to 1 from the low bit to the higher bit? So we're gonna use we're gonna use the OR operation, the binary OR operation. So for example, so this number 1001, it is 9. So what about 9 or 8? We're gonna use n or n minus 1. 9 or 8. 8 it is 1 0 0 0. So what is gonna be the if we use OR operation, actually we just set 0. We just set 1 to 0. Yeah, this is 1. Yeah, let me think about it. This is 9, and yeah, this is 9. If we use OR operation, it's gonna be with 8, it's gonna be 1 0 0 0. It means we're gonna set 1 to 0. But we need to set the low bit 0 to 1. So what about the 9 add 8? So nine or 8 is going to be 9. Yeah, but 9 add 8, it's going to be 8. It's going to be 1 0 0 0. This means yeah, let me use other examples. Maybe I'm not sure why it didn't work. So if we have a number 2, how can we set this 0 to 1? So for example, the number of code bit is 2. This one is okay, but we still need to have another one. Yeah, so it's gonna be 3 and 2. The final answer is gonna be 1, and this is gonna be the minimum number. Yeah, but how can we make it? If we have a number 2, how can we make a number 3? So it's going to be 2 or 2 minus 1. So it's going to be 3. Yeah, because it's for 2, this is 1, 0, and 2 minus 1, it is 0, 1. So by OR operation, it's going to be 3. And similarly, for 9, so we have a number 9, it's going to be 1, 0, 0, 1. Yeah, so for number 8, it's going to be 1, 0, 0, and 0. And then we use the OR operation. So if we use the OR operation, it's going to be 1, 0, 0, 1. Yeah, so normally I need to set the low bit to from 0 to 1. So for number 2, it is okay. I set the low bit 0 to 1. Yeah, let me use another number, maybe 4. I have a number 4, and 4 minus 1, it is 3. And then I use OR operation, it's going to be 1, 1, 1. Yeah, let me just try to finish the coding first, and maybe something wrong with it, I don't know. Number 1, in this case, as C2 is more than C1, I need to set the bit of 0 to 1, the low bit 0 to 1. I need to find the low bit 0 to 1, so I need to use OR operation, or number 1 minus 1, and C2 gonna minus equal 1. So similarly, while C2 is less than C1, so number 1, I'm gonna use the add operation. Number 2 gonna minus 1, and C2 gonna plus equal to 1. So finally, I will return number 1. Yeah, let me just run it. I'm not sure if it works. It didn't. Yeah, so I don't know the binary operation. Maybe I did something wrong. Yeah, I'm not sure. Maybe this is a plus or 1. I'm not sure. Yeah, so it is not minus 1. It is a plus 1 operation, actually, if we need to set the bit. Yeah, let me just try to explain once again. So if we have a number 9, it is 1, 0, 0, 1. So this is a number 1. So n1 gonna equal to 9. It's gonna equal to this number. Yeah, and our set bit for number 2 is 3. Yeah, so basically this means we need to find the low bit of 0, and we need to set this 0 to 1. Yeah, so the final answer is going to be something like 1, 0, 1, 1. But how can we find this number? This means definitely we're going to make the number bigger. Yeah, how can we make this number bigger? And we still need to find the low bit of 0. So we're going to use the plus operation. So number 1 or number 1 plus 1. So it's going to be 10. Yeah, so it's going to be 1, 0. So if this is a bit 1, we're going to plus 1. So it's going to be 1, 0. Yeah. And then we're going to use the XOR operation. If we use the XOR operation, it's going to be 1, 0, 1, 1. So for this formula, actually, we're going to set the bit from 0 to 1, from the low bit to the high bit for zeros. Yeah, so this is why. And for this formula, we're going to set the low bit of 1 to 0, also from the right to the left side. So let's just try. So if this counter say instead of 1, it is equal to 1, what's going to happen? Yeah, so what's going to happen is that we're going to, if this is say equal to 1, yeah, so if the counter of number 2 equal to 1, and we still have this number, yeah, we're gonna set the low bit of 1 to 0. So the formula gonna be nums1 add plus 1. So it's gonna be 1 0 1 0, and here we're gonna use the add operation. So while we use the add operation, so for this the final answer gonna be 1 0 0 0. As you can see, we're gonna set this 1 to 0. So this is exactly what we are doing. Yeah. So basically, I think that's all about it. I think the difficult part is how can we find those two formulas. Actually, this is just the bit operation. If we were to set the low bit 0 to 1, or if we were to set the low bit 1 to 0, we're gonna use this kind of formula to set. Actually, I did something wrong. Here gonna be num1 plus 1. Yeah, let me just run it and submit it to TAC if it works. Oh, it didn't. Yeah, maybe this is I don't know, maybe this is a -1. Yeah, so for the add operation, it is a num1 minus 1, and for the OR operation, it is a num1 plus 1, I believe. Let me just use the same example. So for this one, it's gonna -1. If we -1, it's gonna be this number, and this gonna be, this gonna be the final result. If it is the add operation, it's gonna be num1 -1, because we were to set the low bit of 1 to 0. So so we need to -1, and in this way we can set the low bit of 1 to 0. If we have this number like 1 0 1 0, and we want to set this 1 to 0, what are we gonna do? We need to just -1. It's gonna be 1 0 0 1, and then we're gonna use the add operation. Yeah, as we can see, it's gonna be 1 0 0. Actually, we just set this low bit to from 1 to 0. Yeah, I think it is difficult because we have to remember such kind of formula. Otherwise, we cannot solve it in this way. Yeah. Now let me just submit it to TAC if it can pass. Maybe. Yeah, maybe yes. As you can see, it's really fast, and we passed all testing cases. I think basically that's all about it. Thanks for watching. See you next time.